Hi everyone. Hope you're all doing well. So we'll be continuing this series, right? What is that series we have started? Most repeated concepts of highway engineering in gate examination. We started, and concept one SSD we have completed, and this is your concept two, that is super elevation, right? From the geometry design after site distance, right? This is the most repeated concept you can say if you just observe. Now, so whenever you are having a vehicle. So here this is a flat curve, right? If you just observe, the curve is like this, isn't the curve is like this, right? But what happens if you just observe it, it is not having any super elevation. So this is your curve you are having, that too with the super elevation you are having, right? So what happens? So when curve is not having super elevation, so if the curve is like this, let us say, whenever the curve is like this, right, this is applicable for this condition, vehicle will be subjected to overturning in this direction, outer edge direction. So to avoid this, right, what is it we are doing? We are providing which one? This is centrifugal force, right? So centrifugal force is acting in this left hand side direction. So therefore what is that we will be doing? It is overturning it in this outer edge direction. So then what is that we need to do to overcome this overturning? What is that we need to do? Tell me. So we need to rotate the pavement inwards, right? So that this is centrifugal force P. Whatever the centrifugal force P is acting in this outer edge direction, it will be resisted by this super elevation. You can say if you just observe, right? So this is your inner edge. This is your which one? This outer edge. You can say, is not. Now, so this is your outer edge side. That is your inner edge side. You can say. So outer edge side, right? What happens? Right? Centrifugal force will be acting, right? So here you consider this diagram curve in this manner. Okay, that is one. Now if you are providing this super elevation, right, what happens? It is how it will be there now. So there will be some level difference between this outer edge and this inner edge. That is your outer edge, and this is your which one? This inner edge, right? Level difference between this outer edge and inner edge will provide, that is given with the symbol capital E. And what is that width of this pavement? Width of this pavement is given with the symbol capital B, you can say, or W, any symbol you can give. Now here what are the different forces we are having on a super elevated highway? If you just observe, if your vehicle is traveling on this with some velocity V, centrifugal force P will be acting on this outer edge side. Always it will be acting on this outer edge side. Centripetal force will be acting in this inner edge side inwards. So weight will be acting downwards, obviously. Therefore the slide side or this lateral or this transverse friction is also acting in this inner edge direction, you can say. Like that we'll be having. So now whenever you are considering this super elevation, so that expression for this super elevation, so what is the general expression for this super elevation? You can say, if you just observe, that is your E plus F will be equal to, that is your small v square by this gr, or it is also equal to which one? This capital V square by this 127, or as we have discussed in the previous class, if you remember, whenever it is mentioned as this capital V, means we have to substitute this value in kilometers per hour, or you have to substitute in which one? Meters. So here also that a small v we have to substitute in which units? Meter per second, is not? Or we have to substitute we have to substitute in which unit? Small v, meter per second, you can say. So this g, what is that? Acceleration due to gravity, meter per second square. And what is the unit of this? Or meter radius of this circular curve. We have to select like this. So this is how we'll be having this super elevation expression, right? Suppose if that super elevation is 0, then who is supposed to resist the entire one? Entire centrifugal force? Friction only, na? Which friction? You can say lateral friction, na? That F equal to taken as your 0.15 as per IRC. So what is the F? You can say that is your coefficient of which one? This lateral friction. Coefficient of which friction? If you just observe, that coefficient of this lateral friction, you can say, right? If it is given, you take the you take the given value. If it is not given, you take it is which one? This is a 0.15. Long term friction, you have given the values already now. So F equal to that small v square by this gr, or capital V square by which one? This 127 r. But do you give guarantee that as the speed increases, right, we have to increase the resistance, that is friction also, lateral friction. But as per IRC, are we allowed to provide any friction more than this 0.15? No. Then in that case, right, what is that we need to do? If we cannot increase this friction, we have to only, which one, this we cannot increase this speed also, right? We have to restrict it, right? So then corresponding to this F maximum, we can increase that resistance up to F maximum, we cannot increase beyond that. So corresponding to that, we have to allow certain particular speed, VA square by this GR, or capital VA square divided by which one, this 127 R. So therefore, what is that allowable speed? You can see, if you just observe, we will be getting this allowable speed like which one, that is small VA equal to under root, what is it, you can say, that is your G into that R into that F maximum, or capital VA in terms of this kilometers per hour. If you wanted to get it, first one is small VA means in terms of meter per second, capital VA means in terms of kmph, right? How can you get that? So that is your 127 into that R into that F maximum, right? So like that you are supposed to calculate, right? So in what manner, what is that we are going to calculate? When super elevation is not there, what is the maximum allowable speed to take care of this friction so that vehicle is safe? Is not? Why we are restricting the speed? Because if you are allowing the speed higher than this, vehicle will not be safe now. So you have to be careful. Now, suppose if that friction itself will be zero, then who is supposed to resist the entire centrifugal force? That the entire centrifugal force part will be balanced by this super elevation only, na? So that is E equal to that small v square by this GR. That is also equal to which one? This capital V square by this 127 R. So what is this super elevation called as? If you just remember, if you just observe, this super elevation is called as your equilibrium super elevation, or you can say it as which one, this balanced super elevation. So now at this super elevation is equal to that equilibrium super elevation, right? What is that we are having? Hands free condition will be having, will be having which one, this hands free condition. So hands free condition means, do you need to steer the vehicle or no need to steer the vehicle? No need to steer the vehicle, na? It is no need to steer vehicle. Vehicle takes turn automatically, right? Why it is happening like that? Since the pressure or this reaction on which one, this outer wheel will be equal to pressure or this reaction or this load on which one, on this inner wheel at this equilibrium super elevation condition. So whenever this super elevation is equal to that equilibrium super elevation, so what is that you are having? That this is your vehicle, let us say, the pressure on this outer wheel and this inner wheel must be same. So this is having same pressure as that of this one, right? So that if you are steering, unbalancing conditions will happen, that super elevation itself will be taking care of this turning. That is what you are having. So generally, what is that you can say, super elevation, or you can also write it as which one, this cant, or you can also call it as which one, this banking. What is that given? It is given with the symbol as E equal to which one, this simply that tan theta will be equal to capital E divided by this capital B. Capital E divided by which one, this capital B, it comes to be. So now what is the capital E? If you just say capital E will be the level difference, right? It is a level difference between which one, this outer edge and this inner edge. That is your capital E. And what is the capital B? You can say, if you just observe, that a capital B will be your which one, this width of this pavement, na? Capital B will be your which one, this width of this pavement, you can say, if you just observe, right? And what is that a theta? You can say, if you just observe, sometimes in some of the examinations that a theta will be given. Angle of which one, this angle of banking, or this angle of cant, or this angle of super elevation. When this angle of super elevation is given, right, how to get this super elevation value? Tan theta, right? So now if you just consider as per IRC, right, how this will be considered, tell me. As per this IRC, what is the design we have to go for? First, super elevation required will be equal to 0.75 small v whole square by this gr. So what is that? It will be, that is your capital V square divided by which one? 225, or it comes to be. So this is for which condition? Tell me. This is for this mixed traffic condition. Generally in India will be having only fast moving vehicles traveling in a road, or there will be different vehicles, right? All types of vehicles will be traveling on the same road. Audi car will be traveling on the same road, and auto also will be traveling on the same road now. So in the mixed traffic condition, these low speed vehicles will not allow these high speed vehicles to travel fastly with the design speed. So that's why the speed gets reduced, right? So we'll be designing this super elevation for mixed traffic condition. So why we did not consider friction? Tell me. When it is a design of super elevation, if you are fixing the friction already first, then you are calculating for remaining force to be resisted super elevation. You call it as the design of friction, not the super elevation design. So if you wanted to call it as the design of this super elevation, right, what is that we need to do? What is that we need to do? First, we need to design this road for this super elevation, take care of the centrifugal force by the super elevation. If a super elevation provided is insufficient, then we have to take the help of friction. Then you can call it as the design of super elevation, right? So first we have to give, for which purpose? Tell me. First we have to give preference for which one? Tell me. Super elevation only, to resist this one. Now suppose if that super elevation required or this calculated is lesser than or equal to that E maximum, right? This is your maximum limit provided by the super elevation, you can say. Yes, na? E maximum. Then what is it you can say? Super elevation provided is equal to that super elevation required or this calculated only, right? But when problem comes into picture, the problem comes into picture if it is not satisfying the limits, right? Suppose that super elevation required is greater than this E maximum, means E maximum let us say 7%, but we require 9%. But as per IRC, for mixed traffic condition, to take care of this slow moving vehicles safety, to avoid the toppling or this turning of this slow moving vehicles, right, what is it we need to do? We need to restrict the super elevation to Emax limits only, okay, like that. Then what is it we need to provide? We need to provide this super elevation provided will be equal to that E maximum only. So now, so this E maximum is 7% only we are providing, right? Insufficient, na? Therefore now we have to take the help of friction, this friction, because super elevation is insufficient here. E max plus this F is equal to, that is your small v square by this gr, that is also equal to the capital V square by this 127 r. So whenever you are considering this friction also, so here what happens is that design speed we have to consider definitely, right, like that. Because here we are designing for this 75% of speed only. If remaining 25% speed comes and extra centrifugal force comes, anybody else is there to resist? Yes, friction is there, because we did not use this. But here already friction is utilized and super elevation, both resistances are utilized. And if you are designing it for this 75% speed only, if remaining 25% speed comes, anybody is there to resist? No. So that's why we need to design for this, which one? This is full speed definitely. Then what is it we are doing now? Calculate this F required, na? Get which one? This, what we need to get from here, you can say, get this F required from here, right? Get this F required from this condition, right? Suppose if that F required is lesser than or equal to the F maximum already we have mentioned, na? So what is that friction provided? Friction provided is equal to that friction required only. And what is that super elevation provided? You can say that super elevation provided is also equal to super elevation required only. But when that third step comes into picture in the design, when this third step comes into picture in the design, if we just observe, if that friction required is greater than this F maximum, right? What is the F maximum? 0.15 only. But you may require which one? This is 0.19, right? 0.04 extra needed, na? Insufficient friction is there. Already when super elevation is insufficient, we have taken the help of friction. When friction is insufficient, right, what we'll do? We cannot take any other's help, so we have to reduce the speed. That is the only option. When you are reducing the speed, centrifugal force reduces, so that it will be safe, vehicle will be safe. So which one we need to provide? Friction provided will be equal to that F maximum only, and there is nobody else to compensate that. Therefore, what is that we need to do? We need to reduce the speed enough. We need to reduce the speed, you can say, same way as that of this case now. We have mentioned this case, if you just remember this one. We have mentioned this case at allowable speed. So what is that? You can see, if you just observe, that is your super elevation provided will be E maximum, friction provided will be which one? This F maximum, equal to that small VA square divided by which one? Is it equal to that V square? No, it is not equal to that V square, because we are providing this VA only, no? It is not equal to that which one? This V square by this GR. So that is not equal to which one? This capital V square by this 127. So means it is lesser na actually. So therefore what is that we are doing, tell me? So here you can make it equality symbol, because this is equality between these two, na? Right, here we can write this equality. Therefore what is that allowable speed, you can say, if you just consider? That allowable speed we have to take it as which one? This that small VA will be equal to in meter per second. How much you can say? That is under root, what is that you can say? Small g into that small capital R into what is that you can say? That is your E maximum plus this F maximum or not? Yes. And what is that capital VA, if you just observe? Capital VA is nothing but your which one? This under root 127 into, right, what is that? Capital R into what is that you can say? That is your E max plus this F max. So capital VA means will be getting in kmph, small VA means will be getting in which one? This meter per second, right? Now, is it okay to allow this speed to be reduced? It is better we should not allow. So to avoid this situation, to avoid a reduction of this speed, right, what is that we need to do? We have to ensure lesser centrifugal force comes into picture. How can you do? Now we cannot do, everything is over. But in the starting, when you are selecting this alignment, we can select the curved alignments with this higher radius. Na? Higher radius means even with higher speeds also centrifugal force will be lesser, right? So here, what is that first one? You can say minimum radius. Minimum radius to allow which one? Tell me. To allow this design speed. To allow this design speed with what conditions, tell me? With the full super elevation and this friction usage, na? With the full friction usage and this super elevation usage, you can say. So here in case of these urban roads, if you just observe, so yesterday in the previous session I have given this which one? This is a design speed values, if you remember, urban roads, rural roads. In urban roads, right, what is that R minimum, you can say? R minimum will be equal to that small V square divided by which one? That small V square divided by which one? This is G into E maximum plus this F maximum. G into E maximum plus this F maximum. Or you can also write it as this capital V square by which one? That is your 127 into what? E maximum plus this F maximum. Like that. That is urban roads. And what is this speed you are calling it as? This is your design speed, na? In meter per second left one. In kmph, this capital V wala. Now, but in case of this rural roads, what happens to me? Only one design speed will be there in case of rural roads, or two design speeds will be there? Two different design speeds will be there, na? Right? What are these? You can say ruling design speed will be there. To allow the ruling design speed, what is that minimum radius? You can say ruling minimum radius, right? What is that ruling minimum radius? Equation is same only, small V square by this G into E max plus which one? This F maximum. Or you can also write it as this capital V square by which one? That 127 into what is it? You can say that is E maximum plus this F maximum. What is this speed here? You can say that is your ruling design speed, na? This is your ruling design speed. RDS means ruling design speed. So here, if it is minimum design speed you wanted to allow, right, what is that we need to do? Or absolute minimum radius we have to go for, right? Absolute minimum radius we have to go for, right? Same equation only. What is that? Small v square by this g into E max plus this F maximum, or capital V square by which one? This 127 into, right, what is that you can say? That is your E max plus this F maximum, na? Like that. And what is this design speed you can say? That is your minimum design speed if you just observe, right? Like that. This is your maximum minimum radius to allow design speed with full super elevation usage. Now tell me, what is that minimum radius without any super elevation? We are not taking the help of any super elevation. When you are not taking the help of super elevation means, do we take the help of friction? No. So which step comes into picture? This is first step, na? When the super elevation is insufficient, we have to go for the second step and take the help of friction and take 100% speed. But we are in the first step itself, we are not at all utilizing the super elevation means it is 75% speed only. Which one we have to have? Even though super elevation is not provided, camber must be provided definitely. Okay, like the drainage point of view. So what is that we are having? Tell me. So this is your R minimum will be equal to, what is that you can say? That is your small v square, right? 0.75 small v whole square divided by which one? This g into that camber, or capital V square divided by which one? This 225 into that c. So what is that c you can say? That c will be your camber, right? Camber mainly for which purpose provided? To take care of this drainage, that is camber. This is your camber slope. Even though super elevation is not provided, camber will be present. Camber will take now the duty of the super elevation, you can say, right? Now what is that E minimum you can say? Minimum limits of this super elevation if you just observe. Camber for which purpose? To take care of this drainage. To take care of this drainage. And super elevation should not be greater than which one? This E maximum for which purpose? To avoid what? What to avoid? Tell me. To avoid toppling or this turning of which vehicle you can say? Slow vehicle, right? If you just remember it, what are the E maximum values you can say? Whenever it is an urban road, right, what is the E maximum you can say? That is your 4%. 4% means that 1 in 25, na? 1 in 25, that is also equal to 0.04. Second one, whenever it is that a plain and a rolling terrain, how much it comes to be rate? That is your 7%, approximately 1 in 50, na? 0.07. Next, what is that third one you can say? Hilly terrain if you just observe. 10%, right? 10% means what is that you can say? 1 in a 10, or it is also equal to that 0.1. Next, what is the fourth one if you just observe? It is a hilly terrain with what conditions? Tell me. Snowbound conditions, right? So then what is that you can say? Again it will be taken as your 7%, na? So 1 in 15 approximately, so 0.07. Like that, what is that we'll be having? So we'll be having this super elevation, right? So in the starting, if you just observe, right, suppose if that P by W will be greater than which one? This small f, right? What happens? Tell me. Lateral skidding occurs or lateral skidding do not occur? Lateral skidding occurs. If it is the lesser than f means lateral skidding do not occur, right? Like that you are having. Now if you just observe it, if that P by W will be what? That is your greater than this B by 2H, right? What is that B you can say for this vehicle? Height up to this CG will be which one? This is small h. Next, total height will be which one? This is capital H for this vehicle. If P by W is greater than B by 2H, right? What happens? Tell me. Overturning occurs, na? Now, when it is lesser than B by 2H, right? What is it you can say? Overturning will not occur, right? Got it? It will be safe. You can say if you just observe, right? Now, suppose if you are just going for this last condition for this, suppose if it is which one you can say, suppose if it is which one you can say, if you just observe, if rotation with respect to which one, this inner edge is used, whenever the rotation is with respect to inner edge is used, so super elevation attainment, in the super elevation attainment process, inner edge or outer edge, what is that you can say? The rise of outer edge. The rise of outer edge will be equal to that capital E equal to that small e into that B, is not? So now that is your rise of outer edge, or you can also call it as which one? This is a fall of this inner edge, na? Rotation with respect to outer edge if you are keeping, right? Fall of inner edge. Rotation with respect to inner edge means rise of outer edge, right? What is it you can say? That is your capital E only, that is your small e into B only, right? So this one, what is it you can say? If rotation is in which direction, tell me? If rotation is with respect to this center line, then what happens? So that a rise of outer edge is equal to that a fall of inner edge will be equal to same, na, both capital E by 2, right? What is that capital E by 2? Small e into that capital B by 2, you can say, right? So now this is your super elevation mostly. So these are all your AAR ones, those who secured AAR 1 in GATE 2024. Now, so this is a price at present you are having now. This offer is valid up to this 15th June only. So you can get your GATE 2025 subscription at this 11,999 only. What is that referral code you have to use, right? That RPC will you have to use. So these are the for plus subscription, 8 months subscription available at 11,999. 8 months iconic subscription, it is available at which one? This is 17,999. So what is that referral code we have to use? RPC code you have to use. Now these are the latest batches started, right? These are the latest batches started, you can say on 15th June. Latest batches will be starting if you just observe, right? Now this is for this 2026 civil engineering starting. So here is an opportunity given by Unacademy. So the only launchpad you need to become an educator is what? Perks of becoming an Unacademy star. So you can activate, what you can activate? You can activate compensation and benefits, work with India's large one. You can apply to this one, right? So become Unacademy educator, right? So this is a training program you are having, 12 weeks training program for 50 educators it will be given, and one iconic launchpad also will be there. So it is mentorship by this India's top educators and this industry experts, you can say, right? This is applicable for which one? This JEE, NEET, UG, UPSC, GATE, CAT, NET, everything, right? So you can find a link in the description of the video, okay? How to apply? This is a procedure, right? About those who are passionate about teaching, what you can do? Apply deadline is this one. Everybody can apply. So those who are taking iconic subscription will be getting these printed books delivered to your home within 15 days of your subscription, right? So thank you. Again, next day we'll be meeting with which one? This one more concept, most repeating concept of highway. Thank you.